this video, I'm going to be talking about how we can use the sine graph. Now, hopefully you'll see my last video, which shows you where this comes from. But this is the sine graph, the sine curve, that we need to know and be able to reproduce. Now, we've been reading values off graphs since primary school, so that's a skill that we already have that we can apply here. So if I asked you, what is sine of 80? Approximately, I can use this graph. I can find 80 on the x-axis, which is here. Draw a line right up to the sine curve. Draw a line to the y-axis, and it looks like it's approximately 0.95. Okay, so that's one way we can use the sine graph to read off values of sine. Approximately, what is sine of 370? We're going to do the same thing. We're going to find 370 on the x-axis, which is all the way over here. There we go, there. We're then going to look at where that appears on the y-axis. And that looks like approximately 0.2. So we can approximate these values using the graph. Now, of course, we can also go in the opposite direction. So if I asked you what is inverse sine of 0.5, well, I'm going to go in the opposite direction. So I'm going to read it off the y-axis and then look at where that would be on the x-axis. So I'm going to draw my line in, just as I was before. Oh, but here's a problem. If I tried to find where that meets the x-axis, I've got loads. There's one over here, there's one over there. So there are 6 on the page, but I actually know, because I've seen where this graph comes from, I know that this continues on forever. So actually, these are the 6 values on my screen, would be approximately negative 210 over here somewhere. But we know that there are actually infinitely more. There are loads of answers to this question. So that's not a particularly helpful question, because sine to the -1 of 0.5, so the inverse sine of 0.5, has infinitely many answers in that form. So that's not a helpful question, and you will rarely be asked such an unhelpful question. What you're more likely to get is something that looks a bit like this. So we're saying that sine of x is equal to 0.5, which of course is just a rewritten way of saying that x is equal to the inverse sine of 0.5. And x is between 0 and 360. So this is what we call a restricted domain. So instead of being all possible x's, we are just looking at certain values of x's between 0 and 360. So we are focusing entirely on this box. This is when x is between 0 and 360 degrees. I know that's exactly 360 degrees because I know that that's where it touches the x-axis. Okay. And this then is a manageable question. I'm still getting multiple answers, but not an infinite number. So if I do the exact same process, I draw a line from y is 0.5, and I find where that would meet the x-axis here, and I can approximate whereabouts they are. Okay, so that's about 30, that's about 150. Okay, and in fact, if you remember your exact values, those are exactly 30 and 150. But from my graph, I can see that that is approximately what they are. And of course, we can find different restricted domains. So here I'm going to ask a slightly different question. This time I've got sine of x is 0.4 and x is between negative 360 and 90. So this is just a different restricted domain. If I draw that on, this is the box we're interested in. So x is between negative 360 over here and 90 over here. And again, I know I've got these exactly right because I know that this top of the curve is, well, 1, but that's when x is 90, and I know that we cross the x-axis here at negative 360. So I know that this picture is exact, which is nice. I can then draw on my line at y is 0.4, which is about here. And I can read off my possible x values by going down and having a look at x. And this time we've got 3 possible x's within that range. One over here, and one over here. And if I read them off, we've got these approximate values, approximately negative 335, approximately negative 205, and approximately 25. Okay. What about this question then? X is inverse sine of 0.4, and x is between negative 360 and 90. What could x be? Well, that's exactly the same. I've not changed the question. The only difference is that I've, instead of saying sine x equals 0.4, I've said x equals the inverse sine of 0.4. They were equivalent statements. So it's worth noting that if it's worded like this, then I'm going to do exactly the same thing and get exactly the same answers. Okay, so that's great to get me approximate answers. But I don't want approximate answers. I want more exact answers, or at least as exact as I can be, which in this is to a certain number of decimal places. But I'm not happy with this just reading off a graph and getting something vague. And you may be going, well, sir, why don't you just use a calculator? Well, here's my problem. So if I ask the same question again, x is the inverse sine of 0.4 and x is between negative 360 and 90. My calculator is only going to give me one of the answers. It's only going to tell me that the inverse sine of 0.4 is 23.58. But I know from the last slide that there are 3 answers that match my description. So my calculator is only giving me one of them. And we can see actually there's 23.58. That's what we thought was 25 on the last slide. Okay, so that's quite close. But there must be a value that's a bit near to negative 335, and there must be a value that's a bit near to negative 205, because that's what our graph showed. So how can I find these exact answers without just being able to type it into a calculator? So what we're going to use now is we're going to use the really nice fact that these are mirror images in some way. The values are repeating themselves. If this gap here is actually 23.58, this gap here, I might draw it on to make it very clear. If that gap there is 23.58, then that means that this gap here, this one, is also 23.58, because that's just a mirror image of the same picture. If that gap is 23.58, we can work out exactly what that line is there. Over here we've got negative 180. This point here is negative 180, and we're 23.58 less than that. So to work out that value, I'm going to do 180 take away 23.58. And that's going to give me whatever this x is here. In a very similar way, I can see that this gap over here is also 23.58. And I know that this is negative 360. So to get from here to here, I'm going to add on 23.58. So my other value is negative 360 plus 23.58. And these are then 2 things I can type into a calculator. And I will get my 2 answers of negative 203.58 and negative 336.42. But both of those are awfully close to the 2 values we'd picked. So we've now found the 3 values that we knew existed. We've now found the exact 3 values that we knew existed. So my 3 answers to the question would be 23.58, negative 203.58, and negative 336.42. Okay, then we go through another example. So if we're following the same process, I'm in this time saying sine of x is inverse sine of negative 0.6, and x is between negative 90 and 360. So if I look in that domain, I look here, between 90 sorry, between negative 90 and 360, I can see that I'm going to be getting 3 answers, and those 3 answers are going to be approximately negative 40, 220, and 320, somewhere around there. Now my calculator is telling me that one of the answers is negative 36.87. So on my last slide, I thought that these were the 3 approximate answers, so clearly that matches that one. So my calculator has given me the one that was about negative 40, and I have to work out the other 2 values using my graph. This gap here is going to be 36.87 because it's the same as this gap over here, which we just agreed was 36.87. This gap here is going to be 36.87. So to work out the bits where we're touching the x-axis, these purple lines are touching the x-axis, I'm going to have to do 180 plus 36.87. So we've got 180 plus 36.87 to get to there, and 360 take away 36.87 to get to there, which if I type into my calculator gives me 216.87 and 323.13, which are quite close to these 2 values. So those would be my 3 answers. This gives us a general method that I would like you to follow when answering questions like this, step by step. So we've got a question that looks like sine of x is something, x is between 2 values, find x. Okay, so that's what the question would look like. That's what the last few questions looks like. The first thing you are going to do when you see a question like that is you are going to sketch the sine graph every single time. That's just one of those things that you have to do in questions like this. You have to draw the graph, because as you just saw, a lot of our thinking revolves around the graph, and there's a lot of that even as a mathematician I can't do automatically. I can't see how many solutions there are going to be without drawing the graph and thinking about it first. You need to highlight the domain. So that's what I was doing as a black box. You highlight the domain, so you look at, well, which bits do I care about? You need to draw on the lines. So these are the purple lines I was drawing on, which is where we're talking about on the y-axis, and then where that would be on the x-axis. You use your calculator for just one solution, because that's all your calculator is able to give you. It will give you the one solution. And then you need to use your graph to find the other solutions. Okay, so I'll go through that entire process for a couple of examples. If we've got sine x is negative 0.25 and x is between 0 and 360, firstly I'm going to sketch the sine graph, which looks like this. I'm then going to highlight my domain, which is here between 0 and 360 degrees. I'm then going to draw my purple lines, draw the line y equals negative 0.25, and the line's going to the x-axis, like that. I'm going to use my calculator to find one solution. So according to my calculator, the inverse sine of negative 0.25 is negative 14.48, and that's here on the graph. So actually, this isn't even one of my answers. The calculator's given me something I don't even care about, but that is over here. And so I'm going to try and use that information to find these 2. I'm going to use the graph to find any other solutions. The first one here is 180 plus that 14.48, because that distance there is 14.48, and we've got that added on to 180. And then over here we've got 360 minus 14.48, which gives me my 2 answers, 194.48 and 345.52. I'll go through the process again. This time the question looks a little bit different. We've now got a 9 in front. And of course we can't have that, so I'm going to have to divide both sides by 9 so that we can have sine x equals 5 over 9. And then we can start the process. So we can sketch a sine graph. We can highlight the domain. We can draw in the lines, the purple lines, y equals c, and the lines going to the x-axis. Shows me I've got 2 solutions. I can use my calculator to find one solution. Onto my calculator, the inverse sine of 5/9 is 33.75. And then I'm going to use my graph to find any other solution. So that first one is clearly just 33.75, easy. And the second one would appear to be 180, take away 33.75, which is 146.25. Okay, to finish off, I want to make one slight point that there is an algebraic way to go about this that would not involve graphs. And we call this the sign identities. Now, the reason I would avoid this is that unless you really understand the graph, you are not going to understand these identities. And they're actually quite complicated to remember. So I would instead recommend drawing the graph, going through the whole process I just went through. But just so that you're aware this exists. Now, if this is just x, so this is a general point on my graph now, just any old x value, then I can find 180x minus x over here. I should make clear, sorry, this is any old x value between 0 and 90 at the minute. 180 minus x is then over here. And so that tells me that because they've got the same sine value, they've got the same value of sine, that sine of 180 minus x is sine of x. That's an identity. They're going to be the same thing. In a similar fashion, I can draw on 180 plus x over here, and I can see that sine of 180 plus x is negative sine of x, because it's the negative version of what sine of x was. We can do the same thing with 360 plus x. We can see that that's over here, it's the same as sine x, so sine of 368 plus x is sine x. And finally, sine of negative x is negative sine x. Now again, I wouldn't recommend memorizing this list because it ends up being just as complicated to use this as it does to draw out the graphs, but this is something you ought to be aware of. Okay, key points. We can use the sine graph to find approximate solutions to equations involving sine. Equations of the form sine x equals something have infinitely many solutions, so we need to specify a domain. If our calculator gives us one solution, we can use a graph to calculate any others. And the same thing can be done algebraically using the sign identities.